Okay, this is section 4.4. This is part 2 of 4. We're working on applications of linear systems. We were talking about solving these things with two variables, and so we need two equations. There's a problem. Carly is a bank teller. At the end of a day, she has a total of 69 $5 and $10 bills. The total value of the money is $590. How many of each denomination does she have? Okay, so think about reasonability first. We're talking about some kind of dollar bills, so we can't get fractions, we can't get negative numbers, and we only have 69 bills, so we need numbers between 0 and 69. The other thing to think about is we have this $5 bill thing, and our total amount ends in a 0. We cannot have an odd number of $5 bills and end up with a 0 right here, not when our only other options are tens. So keep that in mind as we go along. We need to set up two variables. So let's say we're talking about our $5 bills and we have our $10 bills. Let's say we have X 5s and Y 10s. All right, and I'm going to be looking for how many of each. So we need two equations. The first one, well, we have 69 total bills. If I take the number of 5s and add it to the number of 10s, I should get 69. Now let's talk about how much they're worth. This is the number we haven't used yet. Each of these is worth $5. So if I had 3 of these, it would be 5 times 3 is 15. Basically, to find out how much money this is, I would take 5 times the number of bills. So 5 times the number of bills. And then we do the same thing with the tens. 10 times the number of tens. Now, I don't know what these values are yet, but I know if I do this, I should get 590. This is the system we need to solve. Now, we need to get rid of one of our variables. It does not matter which one. Both of these are fairly easy since we have ones here. So since they're pretty much equally easy as far as that goes, I could just go with the smaller number. So I'm going to choose to get rid of X. Now, if I have a positive 5 here, I need a negative 5 here. So I need to multiply this entire equation through by a negative 5. When I do that, I get negative 5x minus 5y equal to negative 345. And then I recopy my second one. Now if I add these together, my x's go away just like I wanted them to. I have negative 5 plus 10, so that's positive 5y, equal to negative 345 plus 590 is 245. Divide both sides by 5, and we get y is equal to 49. Now we found y. Y is the number of tens. We were asked to find how many of each. So right now I have 49 tens. Now the rest of this is pretty easy to do in your head, but let's talk about how we would do it if it's not so easy. If I need to take this and plug it back into one of these two. This one looks easier to me. It would work in either one. X plus y, and y is 49, is equal to 69. To solve for x, I need to move this over here, so I'm going to subtract 49 from both sides. And we get that x is equal to 20. Therefore, we have 20 5s. We said that we should have an even number of 5s, and we do. We have whole numbers. We do not have negative numbers. And this one's fairly easy to check. They add back up to 69, so I have the right number of physical bills. And the total value, you know, we're good with money. You could do this. You can check this out.